Welcome back to Aurora Tech Channel. Today, I will review the Prusa XL. This machine started getting shipped out about a year ago, and Prusa sent me this machine a few months ago. Now, I finally have the time and the chance to release this video, and I'm so excited about the multiple tool heads. I actually have a lot to say about this machine, but first, let's take a look at what we can get from the printer. The price starts at $1,999 with a single tool head. It also has a dual tool head version, which costs $2,499, and the 5 tool head version costs $3,499. Besides that, you also need to check the shipping cost on the Prusa website and the import duty of your country. If you get a 5 tool head semi-assembled version to the US, the total cost would be around $4,000. If you get the assembled version, the cost would be around $4,500. It has a 360mm cube print volume. The kinematic is Core XY, and the motion system uses linear rails on the X, Y, and Z axis. The extruder uses the same neck extruder as the MK4 with a 1:10 gear ratio with a large no-slip drive gear. The nozzle and all-metal hot end are quickly swappable. Just untighten one set screw and unplug 2 cables. It supports auto Z offset, auto bed leveling, and auto nozzle offset with an alignment pin at the center of the bed. So, you don't need to print out some patterns like you do on an IDX printer and adjust the offset over and over again. The firmware is their own Marlin-based firmware with input shaper. It doesn't come with an accelerometer, and all values are pre-calibrated. Besides that, with the latest firmware, there's a new feature called phase stepping calibration to reduce the printing noise. For multiple tool heads, it can do auto tool changing during the print, so it doesn't require you to swap filament using the same print head, which could increase the printing speed for multiple colors or multiple filaments, as well as minimize filament waste. The heated bed is divided into 16 individual segments and will only heat up the segments required for the print to save energy. For the print surface, it comes with a satin PEI spring steel sheet. You can buy smooth PEI and textured PEI sheets if you prefer. The motherboard is a 32-bit buddy board with an expansion card slot for multiple tool head upgrades, similar to a PCIe slot on a PC motherboard. For other features, it has 2 filament sensors for each tool head, so if the filament breaks inside the Bowden tube filament guide, it can sense it and pause the print. It supports Wi-Fi, Ethernet network printing, as well as using the USB drive to print completely offline. There is no third-party cloud server required. Everything is done within your local network, and all prints can be sent to the printer directly using the Prusa slicer. It also includes dual 240-watt PSU for single and dual tool heads, and 3 PSUs for the 5 tool head version. I would like to thank Prusa for sending us this machine to review, and I would also like to thank VOXELPLA for sponsoring today's video. VOXELPLA is a brand created by a print farm in Southern California, where they exclusively use their own filament with over 150 3D printers that are operated 24/7 non-stop. This extensive testing leads to high quality and reliability in their filaments. VOXELPLA Pro is a modified version of PLA that provides higher impact strength and supports high-speed printing of up to 500 mm per second while maintaining a flow rate of up to 25 mm³ per second at a regular printing temperature of 210 degrees Celsius. VOXELPLA Pro is also affordable at just $16.99 for a 1 kilogram roll. Ordering 3 rolls comes with free shipping, and bulk discounts are available starting from 6 rolls. They have recently launched new filament colors and other accessories for Prusa and BambuLab printers. For more information, please visit voxelpla.com. The printer you see here is the fully assembled version. As you can see, the machine itself is fully assembled, but you still need to install the tool heads yourself. Each tool head is packed inside a separate box, and they're all identical. Each box includes a tool head, a cable with the Bowden tube guide, a spool holder, and a silicone sock. You have to mount all tool heads at the back, with each tool head mount having 5 screw holes. You need to tighten a screw through the honeycomb panel, so it'd be easier if you use a hex driver instead of the hex wrenches that came with the machine. After all tool head mounts are installed, you need to open up the electronic enclosure and connect some cables. The first and second tool heads are connected to the top, and the other 3 need to connect to an extension board. There are 4 connectors, but only the first 3 are needed. I guess the last one is for future extensions or just for backup. There's only 1 cable for each tool head. I also connected the Wi-Fi antenna cable, then I closed the electronic enclosure and screwed in the antenna. Next, just put the tool heads on the mounts. They're magnetic, so they will just snap in place. Make sure to arrange the cables to avoid interference during tool changing. Finally, connect the touchscreen cable and mount the screen at the front. The hardware installation takes 20 to 30 minutes, and then you can turn on the machine. After selecting the language, the printer will start performing tests and calibrations. Most of these are done automatically, like the heater, fan, and the X, Y, and Z axis. I won't go through each one, but I will highlight the ones that need your attention. The first task requiring careful attention is calibrating the tool head position. This involves unscrewing 2 pins and loosening 2 nuts following the on-screen instructions. The machine will then pick and park the tool head a few times. There should be no wiggling, and your tool head should mount solidly. Repeat this process for each tool head, which takes about 20 minutes for 5 tool heads. Then, it will calibrate the X, Y, and Z offsets for all tool heads. You need to remove the PEI sheet and screw in an alignment pin. The nozzle of each tool head will probe the top and sides of the pin. This part is also automatic, except you need to screw in the alignment pin manually. Each tool head will take about 3 to 4 minutes. Once all calibrations are done, the printer is ready to use. Since Prusa recently launched a new 6.0.0 firmware, I will update the firmware before starting any tests. The stock firmware is 5.1.2. I will download the latest firmware from their website, copy the file to a USB drive, and update the printer. After a few minutes, the firmware will be updated to 6.0.0. This firmware enables the touchscreen feature, but you still need to enable it through the screen menu. Next, I will go to the calibration menu, where there is a new item called phase stepping, which calibrates the frequency of the stepper motor and makes the printer quieter. It starts with the X motor, moving the tool head from the bottom left to the top right, then the Y motor moving the print head in the opposite direction. After about 5 to 6 minutes, it's done. All the items needing calibration will be checked. I will also set up the Wi-Fi. This machine supports both Ethernet and Wi-Fi, but you can't directly enter the SSID and password on the screen. Instead, you export a text file to the USB drive by selecting Create Credentials, insert the USB drive into your computer, edit the file with your SSID and password, and reinsert the drive into the printer. The printer will then detect the file and upload the configuration. When you go to the network settings, an IP address will show up. Besides the IP address, you need the username and password to connect to the printer, from Prusa Slicer to send prints directly from your computer, and to use the Prusa Link web interface to monitor print jobs and manage files. Let's start with a simple print to make sure everything is working. I will print some Benchies at different speeds, starting with the fast Bonkers Benchy from Prusa, which only has a single wall and 7% infill at a 0.3mm layer height. I will print it with Prusa Galaxy Black PLA. The actual printing time for this Benchy is around 12 minutes. When adding heating and probing, the total time is 17 minutes and 12 seconds. The result is pretty good. The 0.3mm layer lines are quite visible, but the surface is not bad. There are minor cooling issues near the top on the side, but the cooling at the front is still okay. Next, let's print a normal Benchy with 3 walls and 15% infill at a 0.25mm layer height. While the printer is running at high speeds, I would also like to check the sound level. It stays around 50 decibels or lower, and during rapid movements it can go up to the low 60s. This one took 29 minutes. Let's compare them side by side. The surface of the 29-minute benchy looks nicer. From the side, there are no issues. For the 12-minute benchy, besides the more visible 0.3mm layer height and some minor cooling issues, both benchies are pretty decent. Then, I will print a honeycomb box to test the retraction and stringing of the extruder. When printing a tiny bit of filament and retracting it right away, it would be a tough print for many machines. The print finishes in 2 hours and 24 minutes, which is in line with all other new clipper machines. All honeycombs can be printed without broken patterns. There's no stringing at all, which is excellent. Let's compare it with those printed by other printers. I think the Prusa XL and the BambuLab X1 Carbon perform the best. Even when zooming in this close, they both look really good. Maybe the XL is slightly better with no stringing, while the BambuLab X1 Carbon has a tiny bit of stringing, but you won't see that unless you zoom in under a macro lens. Up next, I will print the number slider to test the clearance. It seems the first layer clearance is pretty good. You can clearly see gaps between tiles. This print took 3 hours and 50 minutes to finish, which is slightly slower than the 2 hour and 50 minutes to 3 hour average time. The top as well as the bottom should have enough clearance. I would say the first layer is a bit too high, but that should be fine for this model. All tiles can move freely. Then, I will do a tolerance test and see if the parts printed can fit with each other. I will print a simple geometry model, one side with a square and the other side with a cylinder. The print finishes in 2 hours and 10 minutes. It's faster than the average time of 2.5 hours. Let's check the tolerance. I will start with the square. It can clear from 0.225 all the way to 0.05mm, which is a perfect score. For the cylinder, it can also clear from 0.225 all the way to 0.05, which is also a perfect score. Next, I will print a decorative model to test the surface quality. I will print the same Robo Alpaka from Prusa and compare the result with other printers. This model took 5 hours and 58 minutes, which is way slower than the average 4.5 hours. However, the surface quality looks really nice. Let's take a look from all 4 angles. With the latest 6.0.0 firmware, I will also print one from the MK4. Let's see what the difference is with the firmware with input shaper. I also put it inside the Prusa enclosure so I can stack another machine on top of it to save some space. The print finishes in 5 hours and 23 minutes, which is also slower than the average 4.5 hour time, but let's compare the result. The Prusa XL is 35 minutes slower, but the surface quality is even better than the MK4. When compared to the BambuLab P1P, the P1P is about 30% faster, but the XL has better surface quality. Compared to the Creality K1C, the K1C is about 25% faster, but once again, the XL surface quality wins. Compared with the Qidi Q1 Pro, it's 28% faster, but the surface quality of the XL is a clear winner. It seems the XL surface quality is the best among all latest generation printers. The only one that is comparable to it is the MK4 without input shaper that took almost 8 hours to finish. I will also print a PLA sheet to test the accuracy of the Auto-Z offset and auto bed leveling. This is the most perfect PLA sheet I've ever printed, especially for a print bed of this size. There's no other machine that has printed such a perfect first layer so far. Okay, let's try to play with the multiple tool heads. I will create a simple model to use all 5 tool heads. The tool changing is very smooth, there's no wait time, and it just starts printing right away after tool changing. Okay, this print finishes in 1 hour and 38 minutes. It seems all tool heads are working fine, as I can see no issues at all, no layer bending, no offset issues, and no extrusion issues. Then, I will try to print a sample G-code from the machine. It combines 2 PLAs in different colors and TPU. This is a mic holder or box. That box is printed with black PLA, and the inner box is printed with TPU, while the support material uses silver PLA. As the silver PLA support didn't stick with the TPU, it can be removed easily in one piece. I looked up this model from printables.com. It's actually a case for a Rode mic. Since I don't have the mic, this model doesn't seem that useful to me, but it demonstrates how it can print TPU with PLA in one model. Next, I will print a hand bone model. It's a bit creepy, but it uses TPU to connect the silver PLA bone and uses black PLA as support. Okay, this model requires some effort to remove the support, and it just used another color PLA to support PLA, so it doesn't make removing support any easier. The black support has now been removed. As you can see, all the silver bones are connected by the red TPU. It's interesting, but still creepy. There's another sample print, which is a PETG rug box, with PETG latches and TPU sealing. I will mix it with Prusa PETG, VOXEL PETG Plus, and Eryone TPU. This print finishes in 4 hours and 49 minutes. Besides a tiny bit of stringing, the box is printed really nicely. The TPU seal sticks perfectly on the PETG box with 2 latches locked in place. It really seems like an airtight storage box. I will then use Prusa Slicer to slice a multicolor model. I will use white, yellow, red, and black PLA to print this Hello Kitty. To paint a single color model, select the color from the list and adjust the Smart Fill numbers just like how you use Photoshop to select the background of an image. After around 10 minutes, I painted the model with 4 colors. It takes a little over 3 hours to print this model, which is really fast. The filament required for this print is 78 grams. Let's see the difference if we print this with the multiple filament single extruder printer. It takes almost 12 hours to print this model, and the filament needed is 270 grams, while the model itself just uses about 48 grams. Over 220 grams of filament are wasted. 30 grams is wasted on the prime tower, and almost 200 grams is used to flush between changing filaments. For the Prusa XL, the wasted filament is only around 26 grams for the prime tower, and no flushing is required. So, it can save over 70% of filament when printing the same model. My first try actually failed, not because of the tool change, but just because the Hello Kitty has a huge head with small feet. It didn't stick too well to the bed. The first layer actually looks fine, so I applied some glue and tried again. This time the print finished without issues. The prime tower as well as the model stick very well with glue. As I didn't add support, some overhanging areas required some cleanup. I will try to print 6 Hello Kitties at the same time and see if all of them can be printed successfully. When it's about 60% done, the prime tower detached from the bed and knocked one kitty off, but I will let it finish and see. The result is not too bad despite the prime tower and the one kitty, and the rest of them are fine. The damage is minimal, which was unexpected. After some simple cleanup, my Hello Kitty army still looks awesome. Finally, I will print an adjustable wrench from 3dprinted.hardware.com. I will use Prusa PC Blend and a high temperature breakaway support from Fadus. The model took almost 2 hours to finish. When the support material is removed, the wrench can move freely. It's actually quite smooth. Let's talk about the pros and cons of this machine, starting with the pros. 1. The build of the Prusa XL is high quality. It's better than most 3D printers on the market, and the documentation is also top-notch. The print speed is not the fastest, but with Input Shaper integrated in their Marlin-based firmware, it is still in line with the average latest generation printer. The print quality is good, and the print accuracy is excellent. If you use it as a single toolhead printer, it prints just as well as the MK4, but with a larger print volume. Both the print quality and print accuracy is excellent. I did all the test prints you saw in this video using the default print profiles on the Prusa slicer with no adjustments made. 2. With the new phase stepping to calibrate the stepper motors with TMC 2130 stepper drivers, the sound level stays around the mid 50 decibels or even lower. When there is rapid movement, it may occasionally reach the low 60s. For an unenclosed machine, that's pretty quiet. With less noise and less vibration, it should also create a better surface quality. 3. The tool changing works pretty well if you install and calibrate it properly. I noticed some users with early versions experiencing different issues, which I believe may have been caused by glitches from earlier firmwares. I updated to the latest 6.0.0 version, and it seems this firmware is relatively stable, but I'll talk more about this later. Another factor affecting print quality was the early version of the printer, which came with 0.6mm nozzles, whereas the latest machines came with 0.4mm nozzles. I believe some minor hardware details have been improved over time. Installation and calibration are also crucial. I spent almost 2 hours setting up and calibrating the machine. When installing the tool head mounts, you need to tighten the screws through the holes of the Honeycomb panel at the back. Using the wrenches that came with the machine made it quite difficult to apply force, but using my own hex driver was much easier. Overall, I didn't have any major issues with multiple tool head printing, even with my very first multicolor print using all 5 tool heads. 4. The multi-material print speed is much faster than any multiple filament single extruder system. For example, during color or filament changes, the BambuLab AMS requires 2 to 3 minutes to flush out the previous filament, while the Prusa XL takes just a few seconds before the next color starts printing. For instance, if I print one Hello Kitty with 4 colors, using the BambuLab AMS will take 12 hours, but the Prusa XL requires only 3 hours, making it 4 times faster. If I print multiple copies at the same time, such as 6 Hello Kitties, the difference is not as large as with a single copy. The BambuLab requires 19.5 hours, whereas this Prusa XL takes 11 hours and 44 minutes, which is 40% faster. 5. The filament waste is significantly lower. With BambuLab or other multi-filament systems, the filament waste exceeding the amount used for the actual model is very common. While the Prusa XL minimizes filament waste, this difference becomes especially cost-effective when using pricey filaments like PACF, which can cost $100 or more per 1 kilogram. Additionally, when special high-temperature supports are required, the savings can be substantial. 6. Their new neck extruder has a strong pushing force, and the nozzle has an extra long heat break that reaches the gear of the extruder, which minimizes the chance of filament jams and nozzle clogs. I had no clogging issues during the entire testing process. 7. The filament compatibility is better than using the BambuLab AMS. For the large AMS, you may have some issues when using cardboard spools or a non-standard style like a smaller filament spool. For the mini AMS, it requires the center core of the spool to be within a certain size to fit. For some commonly used filaments like Sunlu, I had to make an adapter to use with the mini AMS. For the Prusa XL, you can just use any spool as it just hangs on the side of the machine. The spool holder is also extendable, so you can use some 3 kilogram filament without any modifications of your own. 8. In terms of saving energy, the large heated bed is divided into 16 segments, which will only heat up the area required for the print. This feature can be a significant save for people who live in areas with high electricity rates. However, it would take another 2 to 12 minutes for heat absorption for other areas of the print surface, depending on how large your print is and what bed temperature it requires. 9. Prusa is known for supporting their machines long-term, providing firmware updates and new features, even for older models like the 7-year-old MK3. You can even upgrade it to the MK3.5 or MK3.9, as it's all built on the same platform. So the longer you use a Prusa, the better it performs. For example, when I first tested the MK4, it was a good machine, performing much better than the MK3, but just not super exciting compared to other new generation printers. However, as I kept updating the firmware and slicer, it improved significantly in terms of both speed and quality. Now I also added the Prusa enclosure, and it's become one of my most used printers. For the XL, it already performs well with the 6.0.0 firmware, and I'm looking forward to seeing it continue to improve over time. Now for the cons. 1. Tool head installation and position adjustment need to be done super carefully. Even if you have the assembled version, the installation of the multiple tool heads and alignment still play an important role on how this machine performs. Even if you have the completely assembled version, you still need to install the tool heads and align them yourself. So, it may be necessary to make the fully assembled version even more beginner-friendly, which will require less skill and attention from the user. 2. When calibrating nozzle offset for different tool heads, you have to remove the print surface and screw in an alignment pin. You also need to clean all the nozzles manually. It would be better to have something like the BambuLab A1 cleaning pad, which lets the machine clean itself automatically instead of having the user manually check and clean all 5 nozzles. For now, it only calibrates once when you set up the printer. After a while, when it's slightly off, you can still print, but you may see some alignment issues and you have to manually recalibrate all tool heads using the screen menu. In my opinion, the alignment pin could be permanently placed at the back of the bed. In that case, before a print starts, it can do a fast check on the tool heads you're going to use in the print. This way, it can ensure that the alignments are in line with the existing calibrated values. 3. The Auto Z offset is unadjustable. If you prefer a first layer with more squeeze or more clearance, there's no option to adjust it. For models with a large flat bottom like my benchmark test prints, they were all fine. But for the Hello Kitty print, as the kitty has a huge head and tiny feet, I had to use glue sticks and set the bed temperature to 70 degrees to make sure it stuck well during the entire print. It would be better to keep the Z offset adjustment option under the Tune menu during printing. 4. In terms of printing with the single print head, the speed is still slightly slower than other clipper-based machines. The default print profile is set to 200 mm per second, and the maximum acceleration is set to 4K when printing and 5K when traveling. These values are slower than most other new generation printers, which can generally reach a 300 mm per second print speed and 600 mm per second traveling speed, and 8 to 10K for acceleration. For smaller prints, the total print time won't make any difference, as they don't have room for the printhead to accelerate to achieve a higher speed, but for mid to large prints, the time difference would be more obvious. 5. The Wi-Fi setup still requires you to export a text file from the printer to the USB, manually edit the file to enter your SSID and password on your computer, and plug it back to connect to your Wi-Fi network. With the latest firmware, the screen can function as a touchscreen. Adding an on-screen keyboard to let the user enter their SSID and password directly on the screen would be the much better option. The Prusa Link web interface has basic features to monitor, start and stop prints, as well as do some file management, but it falls short on the Clipper Fluid or mainsail web interface. 6. The number one reason that holds users back from buying this machine is the cost. The machine price, shipping cost, and import duty are all concerns. If you buy a fully assembled 5-tool head machine, like the one in this video, with shipping and import tax, you end up paying $4,500. I understand that making everything in-house in the Czech Republic is not cheap, and Prusa does this to ensure quality. However, making everything in-house for quality control doesn't sound like the best idea. For example, iPhones are made by Foxconn in China and India, Tesla has factories in the US, Canada, Germany, and China, and AMD, Apple, ARM CPUs, NVIDIA GPUs, and many other chips are manufactured by the TSMC in their factories in Taiwan, China, Japan, and the US. These companies have shown that quality control is not a reason to stop outsourcing and building factories in multiple locations, even though their products are much more complicated than the 3D printer. In that case, management would play a more important role. Making the product closer to your market and bringing the cost down is essential, especially with competitors like BambuLab. To survive in the 3D printing industry in the long term, not only do your products need to be advanced, the price must also be competitive. In conclusion, this Prusa XL is the most advanced 3D printer in the market. In terms of performance, the multiple tool head design is definitely better than the multiple filament system with a single print head. However, the cost is also much higher. If you just want to print single color most of the time and print multicolor PLA occasionally for fun, there are much cheaper options out there like those BambuLab machines that can still get the job done. But of course, when printing multiple colors, those machines take a longer time to print, waste more filament, and have other limitations like filament spool selection, and you may also have a hard time when printing flexible filament with other filaments at the same time. If you print pricey engineering-grade filaments and special support filaments regularly, using this multiple tool head printer will save you money in the long term. If you have experience with 3D printing and can calibrate and install correctly, using this Prusa XL will give you a better experience. For the price, it's not cheap, but you can't find other options after the E3D tool changer kit was discontinued, and it also cost almost $3,000. And no one else is building such a complicated machine, so there's no direct competition in the consumer 3D printer market. For beginners, you will need a longer learning curve to make this printer work great, as it's more complicated than most 3D printers in the market. Anyways, we are happy with this machine's performance and appreciate the effort Prusa put into it. It has significant advancements compared to other 3D printers available in the market. I will award it the title of the most advanced multiple filament 3D printer on my recommendation list. I've included its link as well as a link to my website, auroratechchannel.com, where you can find my recommendation list and a price tracker that monitors 150 popular 3D printers, laser engravers, and CNC machines updated hourly. All relevant links are in the description. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.